All right. Hey, everyone. My name is Kuhn. I'm the part of the Stanford Blockchain Accelerator. And yeah, so today we want to talk about shared security and how it enabled the on-chain data industry, some of the new use cases that enable. So to start off, I'll let the awesome panel, the panelist speaker in the panelist to do a brief introduction of yourself and the project you're working on. We can start with Ramkumar. Yeah.
Hi, guys. This is Ram. I'm from OpenLedger. We're building a sovereign data blockchain, more towards AI and anything that is much more interoperable and needed as well.
Hey, everyone. My name is Nate Holliday, co-founder and CEO of Space and Time, Web3 verifiable compute layer for smart contracts and AI agents.
Hi, I'm Jakub, founder, CEO of RedStone. I might have to look younger on the picture because that's my friend Marcin.
Just change. Just change.
Wow, real time. Love it. So we are an Oracle company. We deliver data to other blockchain protocols, protecting around 4 billion in DeFi money and growing really fast.
Awesome. So we have an awesome panel of people expert in the data and Oracle space. So I've prepared a list of questions. We'll go through the list. If I have extra time, we'll open the question so that people from the audience can ask questions. So first off, can you briefly describe your shared security model, and why did you choose to adopt a shared security model compared to using your own security?
I can start. So one of the major reasons that we choose to go with a shared security model and also choose EigenLayer is for obviously the Ethereum security that it provides. We could have gone ahead and had our own validator set, like we could have bootstrapped that, but it's a process, right? It just takes significant energy and time as well. But we see Eigen as a cloud, and within that cloud, data infrastructure has a very important role, like how on AWS there is RDMS and various other solutions. We see us playing a significant role within Eigen for this particular category. And in that space as well, one of the other reasons should be the team of Eigen as well. Sriram and the team, we've known them for quite some time. And Sriram himself wanted to make sure that something like this is being built on Eigen. And he worked very closely with us to do this. So yeah, so the major reason is that, as simple as it says, we didn't want to create our own validator set, so we chose Eigen for that.
Space and Time, we're a shared service provider for the shared security ecosystem. So we help with slashing of staking. We node operators for rewards. Think of Space and Time as a ZK coprocessor. So we're a shared service within the security ecosystem, whether it's EigenLayer, Babylon, or others. But we are going to be launching our own light node within Space and Time, so we are looking at how to deploy that within the shared security ecosystem as well, and we're looking at all the different service providers as well.
So for oracles in general, the challenge is to align the value of assets that we secure and balance that with the security that we get that protects our nodes. So if the market cap of an oracle token is larger than the value secured, then definitely we are overpaying for the security, and happened for some of our competitors. On the other hand, for the newcomers like us, it's a problem that our token may be less valuable than the security we offer to DeFi protocols. So this elastic security is super appealing. We can quite flexibly balance the numbers and offer good protection at an affordable price. But also there's another interesting reason that none of other oracles solved. So it's quite trivial to attack an oracle protocol by accumulating lots of tokens and then performing delivery of malicious data while simultaneously shorting an oracle token. So therefore, being, let's say, financially neutral, we can create an attack vector because we are using the same token to secure the value, as we may also manipulate the price for. If you're using dual staking, that's offering an extra security because it's like infeasible to actually manipulate the super liquid token like ETH while performing an attack on our network. So this gives an extra, let's say, crypto economic security protections against any attacks.
Cool. Yeah, seems like the shared security model can really help to bootstrap the validator set and unlock the security, which is great. I want to also switch angle a bit to more like the end users or the developers, because I think most of you guys are more like infra side. By using this shared security model, do you think what kind of scenario or additional new scenario can be unlocked for your end users, right? And also kind of new use cases for your particular product.
So I'll just give you an example. So we are looking to work with a particular firm which is based out of the EU. So this is more on the traditional side, and they wanted to use our data infrastructure. And one of the major reasons they chose us is because of how it is interoperable, and we can work with other AVSs. So us working with Eigen also lets us work with other AVSs like WitnessChain, which provides like location-based services. So if the EU-based company wants to know whether the data sets or the operators that are operating this data is stored within the EU region, we could work with WitnessChain and provide that information, right? So it enables us to work with other AVSs in the space. So there could be another ZK-based AVS that is there, which we could work for creating proofs. So it just makes us easier to work with other AVSs. That's one of the major use cases that I see for the end user, which is part of the shared security ecosystem. Yeah.
I think that the main use case right now, which is pretty straightforward, which is you have a lot of people participating in the AVS ecosystem, and they have rewards. And they need to be able to reward the node operators. They need to be able to have trustless slashing. And so the bigger the AVS ecosystem grows, and we expect that to grow and continue to grow over a period of time, as nobody's going to, there's a lot of benefit for shared security, and nobody wants to go build it, especially if you're an application or a protocol. So we think that this ecosystem is going to continue to grow. And in order to this ecosystem to grow, you have to have rewards, and you have to have incentives, and they need to be aligned, and you need to make sure that you're slashing things in a trustless way as well. So we think that's the first big use case for us that we're servicing. But there's a lot of use cases that can come after that.
And we as RedStone, we started working with the LSTs and LRTs protocol a long time ago until it was like super hype and sexy. So we're the first one to start working with Swell, Stader, Etherfi, etc. And right now, what's extremely interesting for us is to use this knowledge and start working with AVSs. So being one of the AVSs definitely make it much easier to work with others and offer them the price discovery, which should be one of the most important aspects of their growth and connection to other DeFi protocols.
Okay, cool. So seems like there's some additional token incentive scenarios and additional scenario can be unlocked for the developers, and can't wait to see some the users can potentially tap into those scenarios and develop a more interesting application on top. That being said, I have another question regarding decentralized data, as most of all the panelists are working in the Oracle or data industry. What's your view on data in decentralized systems? And how do you say tap the shared security model to store data, both the transient short-term data and the long-term data?
So we work more on the long-term data than transient data. Maybe someone like the Oracle servers would be a transient data. On the long-term data perspective, I believe, for example, let's take a use case like AI. Someone is creating an AI agent. They would need tons and tons of on-chain data, for example, to create a trading bot, which could be an agent, presumably. For that, you would need data which is probably processed over years and years of, let's say, Ethereum data alone, right? And what we do is basically we store that data on-chain, we create data sets as required, and we provide that as a RAG to any agent that is required. So it is vectorized. It's stored in our vector DB that we support, and they could go ahead and use that for fine-tuning and then making that agent much more better. What really helps us is our architecture, how we've designed on top of EigenLayer. It's sort of like a layered architecture. There's a layer 1 and the layer 2 that we've created, and where the layer 1 is more of a registry chain, and the layer 2s are sort of like sub-database chains. And the data is shared among these sub-chains that are there. So it's much more replicatable. If you want how much of a replications, you can have that. And it's much more scalable because we're not sharing the data across multiple chains, which is usually the case with IPFS or any other storage models. So that is possible with us because we run on top of EigenLayer and use shared security. So as I told you, like a use case like an AI agent would require on-chain data, which is quick, fast, and available. And with this kind of architecture that we build on top of Eigen, that is possible as well.
With Space and Time, it's a decentralized data warehouse. So you have clusters of data warehouses all over the world being run by node operators. It's typically long-term data. You do transaction and analytic processing within those clusters. So you don't have the lag time between, if you look at a Web 2 solution per se, a Postgres and a Snowflake and ETLing all that data. I think what makes it unique as well is we ingest the major blockchains with verifiable indexing. So if you want to ask questions about what's happening on chain and you want to connect that with off-chain data, you're able to do that within this decentralized network that we don't own. It's the node operators that are running these in a decentralized cluster. But it's important that these are data warehouses that are clusters, right? It's not individual databases sitting all over the world, because you wouldn't be able to do big data sets without the clusters of data warehouses.
We work with data in two flavors. So the first one is the transient data. That is extremely low latency. So that's the data that comes from the markets, and we put it on chain as it price fits. So that's like a totally different needs in terms of the performance and availability. And the second flavor is like a fully permanent data. So what's unique about RedStone, we store all of the information. So not only the feeds, but also the sources, etc. And currently we use Arweave for that, but obviously we are very interested to see what's going to happen inside the shared security for like truly permanent storage.
Cool. The other last question I have, I think some of you guys already answered it partially. Then Ramkumar maybe already partially answer or address the question. But feel free to elaborate if you feel like you want to add more. So what made you choose a particular security platform like EigenLayer or become an AVS? And also going forward, what might change your choice of a particular a shared security platform?
So I think I've answered you on the architecture part. On the other side, the services that we would cater to, or we are already catering to, is very varied, right? So it could be, as I told you, an on-chain AI agent or a simple dApp, which is using our solution. So the security that we would need could be varied. In the end, in one side, it could be an agent that is trying to process an order which is worth $1 million, and then a dApp which is just providing an on-chain information that is requested by a user. So for this varied security, we would need a very abstract way of doing things, right? And someone like Eigen provides that. I could choose what kind of security I need based on the services that we provide. So I think that is very important. If we are having our own validator set, we would be paying a much more higher fee than that is what actually is required. With Eigen, it could be just varied. So yes, so that's probably one of the major reasons why we would work with a shared security model like Eigen.
Yeah, for Space and Time, we're a service provider within the shared security ecosystem, so we can have our sub-second ZK coprocessor, which is relatively fast and very cheap to process. For example, I already talked about slashing and token reward incentives for node operators. I think your second question, which is what are we looking for within an ecosystem for it to be successful? I think ultimately as we step back and we look at like where do we want to put the most engineering resources in the ecosystem, the question really comes back to how are these applications and how are these protocols growing within these AVSs, within these ecosystems. So what I mean by that is there's a lot of incentives being given out, and all of these AVSs are going to have to grow, right? They're going to have to generate revenue, or they're going to have to generate users. They're going to have to generate something to create this demand. And I think ultimately over a period of time, like, you know, the ecosystem that can meet the demand of the incentives is ultimately going to be very successful. And so for us, you know, watching that and making sure that, you know, we align to the ecosystems as a service provider, but also ultimately the success of this comes down to, can they generate the users and the revenue needed to pay off the incentives?
Yes, I would say that's very early in the risk-taking ecosystem. The players are just building up their positions, their network, etc. For us, there are like three factors. What is the cost of capital? Definitely. We want to have the security as the most affordable price. Then what is the actual performance of the cost of verification, the cost of rewards distribution, all of these technical details that can affect like how expensive our Oracle service is to be consumed. It's often overlooked, but it can play a major force in the future. And obviously, what is the market? Whether there are like a major AVSs that require the Oracle feeds. And definitely the demand will also be like a very important factor for us to pick and choose what underlying platform we use.
So we have a few minutes left. I'm just wondering if anyone from the audience have a question.
Hey guys, so one of the reasons I was excited about this panel, like, you know, we talk about the cloud analogy of this space. You know, we've got two companies up here specifically that started with databases, and someone else started with databases, AWS, S3. You know, where do you guys see yourselves in this ecosystem strategically? You know, the cloud world today, you know, Google Cloud, AWS, they bundle all these microservices. And, you know, they basically give away the orchestration for free. How do you guys see the space evolving? I mean, you guys are building databases, you're, you know, building using, you know, you're using shared security, but you've got multiple other services you can layer on to what you're doing for your customers. Is that going to be something you do yourselves? Is it going to be something that you open up to other people in the ecosystem? Is it both? How do you build that trust with those other AVS partners? How do you think about it? Is everything going to be, you know, space and time or OpenLedger basics? You know, or is it going to be, you know, how's that all going to play out?
I'll take a quick shot at that, and I'd love to hear your thoughts as well. Look, I think AWS and Microsoft did a great job of, you know, commoditizing the edge. And if you're not giving away orchestration and the APIs and the data storage, I think you're going to have a really tough battle ahead. For space and time, the way we think about it is storage is free, ETLing is free, indexing of data is free, the ability to even have database computation between a transactional database and an analytical database, an HTAP database that we build. Ultimately, that's free as well. Where we're trying to drive value is in the verifiable compute. And the thing that AWS doesn't have and Microsoft is trying to build with us, and Google's already announced of building with us, is taking our proof of SQL or our ZK proofs and embedding that into their Web 2 databases. So the ability to verify whether you're a decentralized database or a centralized database, whether you're a large cloud ecosystem or a small, being able to verify the actual computation is something that we're going to continue to lean into, because we think ultimately if you're building on the edges, you're going to be forced to drive computation. And if computation basically is actually commoditized as well, the verifiable compute, we believe, ultimately becomes a stepping stone and a step different than what you can even find in the Web 2 orchestration of databases and the various clouds.
So to be honest, we are still figuring out this, you know, the answer to this one. because most of the Web3 projects, if you take a look at it, right, when you approach them and you talk to them and you say there is a solution like this, they would be like, I could do this with AWS, right? But what they don't realize is that then why are we building in Web3, right? Everything could be non-verifiable, censored, and centralized. So I think it comes down to the teams that are building the space. If they want their data to be interoperable, if they want the data to be permissionless and verifiable, they would use a solution like this. Yes, that means that you need to go through a compromise, like let's say latency. But I think we are evolving to a space where we'll be as good as AWS down the line, right? So it is the intent, I would say, among the builders on how they want their data to be stored and how they want their data to be accessed. So it comes down to that. And we've seen that happening with the players that we speak to. And once we tell them there is a solution like this, which makes your data much more open, because we are a real-time database, right? And what Space and Time and all these guys are building is something different. So for that, you would need to use that within the product itself while we are building it. And it comes down to the intent of the team, how they want to have their stack. And if they wish the stack to be completely permissions and verifiable, they would go ahead and use that. And the space would evolve as it goes, as more and more people start using this. That's how we will start building toolkits on top of that. That's how AWS was built, right? As they started working with people, they knew that certain things are required. So that's how I see this. It's a ever-growing space. We are still exploring and figuring out what is the best needed for these devs who are building in this space. So let's see how it goes.
Awesome. I think the question actually Adam asked is perfect ending question as we're trying to draw an analogy of AWS and the shared security and how far away are from like bridging the gap between Web 2 and Web 3 and why would people use shared security model. And for right now, it's for permissionless and kind of verifiable and what's kind of the missing piece. So I think it's a great kind of ending question to finish the panel. So now time is up, and thank you guys for your time and sharing the insights.
Thanks for having us.
Thank you.